Hey everyone, this is Bathymetrics, and today I'm going to be talking about part 2 of my deep dive into voice handling. If you haven't seen part 1 yet, I recommend you go watch that, because in part 1 I talk about the mono voices versus the poly voices. I talk about retriggering, the legato retriggering. I talk about key stealing, and I explain a lot of that stuff. Plus, I also talk about the glide and legato settings. But today we're going to talk about voice stacking, specifically about how to do unison in Bitwig devices. So first things first, let's go take a quick look at Serum. And just briefly compare how other synthesizers tend to do their unison handling. Usually in any given synth, there's some sort of dedicated unison section, and you can create unison voices up to 16 in some synths, maybe less in other synths, and you can set the amount of detune for each of the individual voices. And you can also, in some cases, set the blend of the center voice versus the outer voices, which can help with monocompatibility. For example, if I have just 4 voices here, it can really help with monocompatibility to make the center voices a little bit louder than the side voices. And then depending on the synth, there may be additional settings for unison that let you do more than just affect the unison detuning and the stereo width. Like Serum lets you also adjust behavior of the warp table, the wave table position, and even the type of unison, whether it's linear, for example, or exponential. Like now we can see that the outer voices have this kind of exponential spread to them, right? As opposed to a symmetrical spread or linear spread. We go back here, you can now see that they're back in an even linear spread. So it all depends on the synth. Every synth has their own implementation. All unisons sound and behave a little bit differently from synth to synth. But today I'm going to be talking specifically about how the Bitwig devices work in this regard. So first off, I don't actually use all the Bitwig devices that much. I mostly make use of polysynth and phase 4 because I really like the way they sound and their overall quality and features. And first I want to talk about polysynth and phase 4, the standard older Bitwig instruments, because they behave a little differently with regard to unison. In polysynth, we have a standard saw here, just a basic saw wave. And you don't have to use the voice stacking features in polysynth to get unison because they've built in a basic unison right here. So if we say right now it's single voice, but if I make it something like 5 voices, now we have this nice wide unison, and they give you a stereo control to control the width of the unison. And I'm going to use a few meters to show you the width. So the spectrum analyzer is set up to show mid-side balance. And the orange line represents the side signal. And typically you want the side signal to always be a little less than the mid signal. Otherwise you run into monocompatibility issues. So we can see that the orange line is a little bit less than the blue line pretty much all the way across. And so that means when we collapse everything to mono, we're not going to lose too much power. Listen to the difference. Now we're losing a little bit of power. So right now the unison is at full stereo width, but if I drag it in, it now becomes very mono. I mean, there's still some width there. It's different than not having unison at all. But you can see how the side signal now is much lower than the mid signal, and so that means it's incredibly monocompatible. Listen now. Like there's almost no difference in the perceived loudness or power of the signal, whether I'm in collapse to mono or not. So usually we try to find a balance between the widest feeling sound when it's in stereo and yet not losing too much power when we go mono compatible, because I don't care what genre of music you produce these days, if you're not paying attention to mono compatibility, you're really doing it wrong. Because it may sound great in your studio on two speakers that are 3 or 5 or 6 feet apart and equilateral triangle to your head. It'll sound great on your headphones. It'll sound great in your car, even maybe, depending on how your car's set up. But so many of our fans who listen to our music hear them on crappy mono systems one way or another. They're playing it on their iPhone, or they're playing the song on their crappy laptop with two speakers that are very close together, and it's 2 feet away from your face, so they might as well be one mono speaker. Or they're using one of those Bluetooth speakers that's just a big mono brick, even though it's loud. And there's just tons of places where they're going to hear your music in mono, no matter what you do, no matter how great it sounds in stereo. So if you're not paying attention to mono compatibility and making sure that any given sound in your mix doesn't lose too much power when it's collapsed to mono, your mix will sound totally different on somebody's crappy mono Bluetooth block than it does in your studio. So you have to pay attention to these things. And I use Bitwig's oscilloscope and spectrum analyzer to, understand what's happening in the stereo field with the width and the mono compatibility. And I find the spectrum analyzer in mid-side mode is super useful for letting you see at a glance whether or not something might be mono, might have some mono compatibility issues. And so, if we find a good balance between the widest possible sound and almost fully mono, somewhere in there's a balance point, an optimal trade-off between stereo width and mono compatibility. So let's try and find that in this polysynth patch with their standard built-in unison. See, those two are almost indistinguishable power-wise. I'll try and go a little bit wider. Okay, so right about there, you start hearing a noticeable dip, but it's not so bad. In a mix, it's probably not going to hurt your mix that bad if that sound drops by that amount of loudness. So, this is the kind of game we play is mid-side control, essentially, to help with the monocompatibility of unison voices. Now, I'm showing you all this up front because it's going to be important later when we talk about how to get monocompatibility out of unison in a grid device, because that gets a little trickier. So polysynth is the easiest to understand and wrap our head around because it works like a lot of our third-party synths like Serum. It has a dedicated unison section. Now let's move on to phase 4, which does not have any kind of dedicated unison controls to it. So we have a basic saw wave again. And I've got the same set of scopes here. We can see that it's just a completely mono signal now. There's no difference between left and right, and there's no difference between mid and side. Okay, so the way you would get a unison kind of sound out of phase 4, or pretty much all of the other Bitwig instruments besides polysynth, is you would click on the header of the instrument to get to the voice controls, and you would crank up the number of voices. Now, here's an important thing to note. Look at the volume level of this track right now. I'm peaking at negative 3.7 dB, and the RMS is basically at about negative 4 dB right here. So the first thing that happens if I crank up the number of voices to the maximum, which is 5 voice stacks, watch what happens to the volume now. Sorry about that. Did that on purpose, just to show you that what's happening by default when you first turn on voice stacking is it's literally creating 5 different copies of phase 4 in memory. And all 5 of those copies right now are exactly identical in their settings. And so it's effectively summing like 5 tracks worth of phase 4. And so you get that huge volume jump at first. You can see that everything looks like square waves now because the actual peak of these saw waves is beyond the bounds of the oscilloscope. So first thing you have to understand and remember is usually when you crank up voice stacking, you want to immediately come over and find your volume output for whatever engine is making the sound and drag it down and just kind of balance it back to where it was. Just probably about there. Let's double check. I want to get to about -3, -4. A little higher. It's a little too loud. All right, because I want you to be able to hear me talking over this. So again, our RMS is about -4. Peak is -3. I'll even take this down just a little more. Okay, so now we've got 5 voices in play, but we haven't done anything with them yet. We haven't created any unison. And the way you get to unison, there are 2 ways. One is in this very basic, simple voice stack spread button that appears in the same area as the other voice handling options. And what this is a symmetrical, linear, bipolar spreading of values. So I have 5 voices, which means the third voice, the one in the middle, is exactly at the current value you see anywhere in the synth. But the other voices 1 and 2 are a little bit less, and the other voices 4 and 5 are a little bit more. So for example, if I click this modulator button and come over here to the oscillator we're hearing, and this is the detune frequency, right? If I take this and drag it up just a little bit, usually about 600 to 900 is a good amount for unison sounds. I've now taken this frequency offset, which it detunes the right channel relative to the left channel. That's how this works. And it slightly changes the pitch ever so slightly. Now, I've done that on all 5 copies of this phase 4. You don't see any difference here, but if you hover over this value, you can see it's highlighted and there's a little darker green line underneath that shows that a certain amount of modulation has been placed onto that value by this voice stack spread. And what it's doing under the cover is the third oscillator is exactly at center, the third voice rather. The second voice is at probably about 0.5 of the total spread. Like this maximum offset is 0.69. So voice 1 is -0.69. Voice 5 is positive 0.69. Voice 2 is probably around -0.34. And voice 4 is at positive 0.34. And then voice 3 is right here with the setting we're seeing here. So under the covers, there's 5 copies of this synth. And the only difference is that what we see here in front of us is basically the third copy, the third voice. And so now we're going to hear a detune. And we can see the detune behavior right here. Now, it's not in stereo yet. This is important to note. We have 5 voices. They're all interacting with each other. And let me maybe turn this up a little bit. Yeah, let's turn it up just a wee bit. All right. So there are 5 voices. Everything's still in mono. So all 5 of those voices and their detune are interacting with each other, and we no longer have a simple saw wave. We have 5 voices that are phasing with each other as their different frequency speeds cross and blend with each other. And it's always retriggering from all 5 voices starting out in phase, and then they drift out of phase, and that's why it always looks like the regular saw wave when I first hit the button, but then it starts breaking apart into 5 saw waves. And then they start phasing with each other. And over here in the frequency spectrum analyzer, this is what phasing looks like, right? So all these frequencies are doing strange things. Okay, so how do we get stereo out of this? How do we make this sound in stereo? Because, I mean, we detuned it. Where's the stereo? And even if I click this button, which is a different thing I'll show you in a second, it's still mono. Okay, so how do we make it stereo? Well, just like in Serum, when you run a detune, you're detuning both. I'm sorry, when you run Unison, you're running a unison spread on the detune for the oscillator, but you're also applying that same exact unison spread to the stereo pan of the oscillator. So we can duplicate that in Bitwig by clicking this modulator again, coming over to our left-right button, and let's crank it all the way up to +1. Now again, we're looking at the third copy, or the third voice out of the 5 voices, so it doesn't look like anything changed, but under the cover, voice number 1 is sitting over here at extreme left. Voice number 2 is panned to about this position. Voice number 4 is panned to about this position, and voice number 5 is panned to about here. So it's going to sound and look like this now. And now we have stereo. So you can see that the left and the right channel are slightly, they start out together. Again, when it triggers, everything's in phase. So it's pretty much almost mono on that very first tap, the very first attack. But then it's going to quickly drift the left and the right out of phase with each other. Okay. And then we see a difference in the mid and side signal. And I can tell just by looking at this diagram that we're in, or this scope, that we're in pretty good shape monocompatibility wise, because the orange line is noticeably low. I'm sorry, the blue line, yeah, the orange line is noticeably quieter than the blue line. So if I mono this, we're not losing too much power. That's a very monocompatible sound right out of the gate. So, you know, this is the basic trick for unison in almost all of the Bitwig instruments, except for polysynth and polygrid. We already talked about polysynth because it has its own built-in unison that's pretty perfectly balanced. I mean, all you have to do to get monocompatible is maybe adjust the actual spread on the stereo field, but that's it. Okay, phase 4 is a little more forgiving and friendly with unison, because if you just give yourself a nice amount of offset on the detune and, you know, give yourself a nice wide pan, or if you wanted to drag it more mono, we could do that. Let me, I'm just going to take the pan. It was spread all the way to the extreme left and right for the outer voices. But if I drag it in, watch what happens here and watch what happens here. Oops, I went too far. Let's go to 0, close to 0. See how this looks almost mono? There's almost no difference between left and right. It's almost like it's back to just a mono detune with just a tiny, tiny difference between the left and the right channel. You can see a little hint of orange along the edges there. But over here, we see the real difference, which is that now the side signal, the orange signal, is much quieter than the mid signal. So it's practically mono. And as we start cranking the, yeah, I didn't need to open that again. As we start pushing the pan upward towards a full modulation value of 100%, we're going to see these orange and blue lines get closer together, and the sound will become more wide in the stereo field again. Okay, so that's all the other older instruments like phase 4 and so on. Now you can go a step further and assign this same linear bipolar voice spread to lots of other parameters if you wanted to. You could be making the filter behave differently for each voice. You could make the ratio behave differently. You could make the shape of the oscillator behave differently. You can assign this to as many things as you want, but the basic unison is detune plus stereo width. And then you kind of control how wide the stereo is to make sure that what you end up with is essentially mono compatible. And you don't lose too much power when you go to mono. Okay, so far so good. Now where it gets a little different is in polygrid. Polygrid, we have to build a lot of this by hand because polygrid by default, when you start out with an oscillator, it's just a basic mono oscillator. And you have to use voice stacking to get unison out of it, but there's a few little tricky differences about the way unison works in a grid device. So that's what I'm going to spend time showing you now, are some tricks for doing this. So let's see what's going on with this patch, first of all. And let me also make sure that we're hearing this one. Okay. I've just built a few things ahead of time to make it easier for us to examine what's happening in the stereo field, the left and right channels, versus at some points I'm going to want us to listen only to the mid signal or only to the side signal. So that's what this whole splitter into the mixer is about. Right now, the only two voices that are active are the left and right channels, and each one is panned hard left and hard right, respectively. So it sounds a lot like what we've been hearing. We have a mono signal, no difference between left and right, no difference between mid and side, and we're just hearing the full stereo signal right now. Over here, I've just added this mainly to help us see and control the volume levels once we've added voice stacks. Right now, there are no voice stackings. This is just a mono voice. And I'm paying mostly attention to where the little VU meter is sitting at. And again, if you're not familiar with that, that's one of the display features you can use. It's very handy sometimes. So we have a mono voice. And if I turn on voice stacking, 5 voices, watch what happens here and watch what happens to your ears. Sorry about this. Okay, way too much volume, because again, we now have 5 different copies of this polygrid. This build now exists 5 times in memory, and all 5 of them are being played simultaneously and summed together. And right now, there's no difference between any of the 5. So they're just effectively summing and turning into this big, huge square wave again. So again, just like with the other Bitwig instruments besides polysynth, as soon as you turn on voice stacking, grab a gain control from the level group. I'm using gain volume, and just drag it down because you're not going to want it that loud. And just sort of, adjust it until you're more or less at the same level we were before. I'm looking for a certain height in the orange bar there. Okay, so now that we've adjusted the gain, that's about where I want it. Now we can actually start playing with the unison. So again, every oscillator has a detune setting right here. And the way you start creating unison is, again, by grabbing the voice stack spread and pushing this up to somewhere between like 600 and 1. And I'll show you why those numbers are magic in a second. So now we have detuning. And because it's getting a little quieter again, because of the way detuning works, I'm going to put the volume about there. Okay, so they all start out in sync, and then they slowly start drifting apart in their pitch from the detune. And so at first it looks almost like a regular square wave, but then you can see them starting to spread. Now, in the grid, you have control over that initial trigger and being in sync. You can't do this in, for example, phase 4. Phase 4 always triggers all 5 voices in sync. But in the grid, you can use this precord or some external trigger logic you've built. If you turn off the precord, now those 5 voices, or that the detune is constantly drifting in and out, whether I'm playing notes or not. So watch what happens now when I hit notes at different times. Watch here. See how they appear to start at different degrees of phasing with each other? That's because they're just free running right now. There's nothing making them sync up again. But if you click this precord, that makes the entire oscillator and everything about it re-trigger in together at the start. Okay, so that's number 1. If you want it to sound like all the other Bitwig instruments, turn this on. If you want it to be different and just constantly free run, turn it off. And by default, this is off, so that may confuse you when you test Unison in here the first time. I would recommend just get in the habit of turning on trigger when you're going to be working with Unison and voice stacking. Okay, so next thing, we've done the detune, but it's still in mono. So how do we turn it into stereo? Well, if we click this button, this is normally what turns on the stereo output from an oscillator. And technically speaking, it's always putting out stereo, but right now it isn't detuning. Well, it's detuning, but it's detuning in mono because this little button right here is off. Now, if I turn this button on, you would think it's now putting out stereo, and we should see stereo behavior here when we play. But we're not. Why? That's because even though it's triggered to recognize some sort of difference between the left and the right channels, you have to nudge this a little bit to get it to actually start detuning. Like if I kick it up to 0.01, now we have the stereo detune. Now it's affecting stereo. If I double click it back to 0, it's going to be back in mono again. Because I've double clicked it to set it to its default, which is exactly 0. And then this is an important, tricky, weird, quirky nuance of the grid and the grid devices. If I barely touch this, I'm not actually changing it to 1, but I've nudged my mouse just the tiniest bit. So it still reads as 0. And we can't really tell what it is under the covers. There's nothing to really read this value for us in its exact setting, but it's not quite 0 anymore. And watch what happens. Sure enough, we have some stereo detune. So you want to get it in mono, double click it. If you want it in stereo, put it up to like 0.1, 0.2, or even just barely nudge it off of 0. And now the next thing I want to show you is notice that unlike it for phase 4, putting even the slightest amount of stereo detune on it, we've got a side signal that's almost identical to the mid signal in terms of power. See how this orange line is right on top of the blue line, especially up here in the high frequencies? That's problematic because that is definitely not going to be mono compatible. Watch. See how we lose so much power there? That is horribly not mono-compatible. So we're going to have to play some games to fix this, and I'll be talking about that in a moment, and that's why I built all this. But the main point is there's another potential way to achieve a stereo detune, even if you're starting out in pure mono like this. Like, you don't have to kick this into a stereo output and then spread it ever so slightly to get stereo behavior. We could try to build a pan control into the signal coming out of this oscillator and mess with the pan. Basically assign a voice stack to the pan. So let's try that. Let's go find mix. Where is pan anyway? I mean, I know we have pan in the mixers, but I wonder if there's just a simple pan control somewhere. I've honestly never looked for something like that. Okay, I think we're gonna have to use a single mixer right here. It's just one channel. We're gonna leave it at the default volume, but here's our pan control. Here's full left. Here's full right. See how over here the saw wave is on the blue signal? That means it's fully right. And if we flip it over here, the sawtooth will now be on the orange signal, which means it's fully left. Okay, so right in the middle should be stereo, but again, there's no difference yet. But if we take our voice stack and we assign it to the stereo knob right here, go all the way up to 1, and hey, that's looking a lot better. So that's the first thing I want you to notice. This is fairly monocompatible because that orange line is lower than the blue line, and we can see it here. It's losing a tiny bit of power, but that's almost good enough. But again, if we wanted to adjust this slightly for better monocompatibility, all we would have to do is grab the width control right here, stereo width in the mix section. This is like the same width knob in Tool. So now if we drag this up or down, you're going to see the relative level of the blue and orange lines change here. So that can make it very monocompatible. Or we can push the sides even louder than the blue and make it really uncompatible. Here, let's make sure we're listening to it in stereo. Here's default. Really wide, but not at all monocompatible because the sides are too loud relative to the mids. But if we pull the sides down a little bit more than default, now we have a nice monocompatible signal. Almost no difference there. Let's make it a little bit more like that. So that's a good monocompatible level right there. About 80% inward towards center. Okay, so it's really important to think about monocompatibility in the grid and use some intelligent scoping to help you, like, at a glance, see and understand, not just necessarily hear. And the reason it's important to do this in the grid on any one oscillator that you're putting Unison on by using voice stacking, it's important because in the grid, we can combine a whole bunch of oscillators, right? And not all of them are going to be in unison, or they might have different amounts of unison, different amounts of spread on any given parameter. If you have something like a sub oscillator in here, a sine wave that you're using as a sub, and you're mixing it in and layering it with the other oscillators in the grid, you're gonna definitely need to, like, do this monocompatibility check and adjustment on individual oscillators, because what you wouldn't want to do is put like this sawtooth with a wide unison and then a single sine wave that you're using as a sub signal, and they're layered together, so you have a nice fat sub under a kind of supersaw, kind of supersaw. And then you wouldn't want to go into the FX container for the polygrid and do your, like, mid-side balancing there, because then you're going to be messing up the mid-side balance of the sub, and you don't want to do that. You want to leave the sub alone. So just remember this technique as you're playing around with Unison. You can simply drop a mixer and add your voice stack to the stereo on the mixer to get your stereo spread. And then you can use a stereo width module to fine-tune the monocompatibility. And I show you this because there's another way to do kind kind of, sort of, kind of unison in the grid or some other instruments. And I'm going to show you that now. I'm going to get rid of the detune. And we're back to just a simple mono voice. And I've set these back to center positions. So now we just have a mono voice. Let's turn off the voice stacking even. So now we've got a single sine wave. Make it louder again. Okay. So the thing you've seen in some of the Bitwig videos, from Bitwig talking about, hey, this is the grid. And, there's at least a couple of them that talk about, well, if you have an oscillator and you want to make it sound stereo, they don't even talk about voice stacking. They just show you the simple 2-voice detune, which is built right into every oscillator. So the way that works is it's mono right now.
Come on.
Sorry for my dog. It's built into the oscillator. You just turn this on to make it start putting out a difference between left and right, and you detune this until you start hearing a difference. So I find usually somewhere between like 20 and 33% is about as far as you want to go. Otherwise it starts sounding sour. Right? That's no good. You want a very subtle amount. And again, we can see its behavior over here. But look at this. This is the problem. It sounds good in your headphones or on your monitors, which are nice and stereo. Watch the mono. Way too much power loss. What I'm saying is, this basic technique, don't use it. Just don't. I mean, it works. And if you truly only care or think that people are only ever going to hear your stuff in stereo, great. Go ahead, use it. But you don't have as much control over it. I mean, you can throw on a stereo width module and drag it down to help with that. So sure, if you want to do that, go ahead. Maybe that's easier. The other thing to note is that this is and we're just going to look at the mid channel now. This is a 2-voice oscillator. It's basically taking the left channel and the right channel and spreading them apart with a tiny bit of detune. And that's what's creating 2 voices that move out of phase with each other after they start. See, they start together, and then because it's a positive phase adjustment, and this phase is affecting the right channel, you can see the blue colored right channel, right after the hit, it starts moving in this direction because it's a positive phase. It's moving a little bit faster, okay? Now, if I turn this to a negative value, and this little thing flips upside down to show now you're doing a negative detune, now watch what happens. This time you're going to see the blue right channel splitting off in this direction. And just as a point of interest, here's another kind of scope I use to help me understand what's going on with my stereo field. It's a free plugin by Melda plugins, and it's awesome. It's really good. This is a correlation meter. Basically, as long as you're in the green, you're still mono-compatible. If you start getting into the blue or red, you're kind of pushing the limits of what is potentially mono-compatible. Let me put this back up to this. See how we're skirting the line between negative correlation? As soon as it turns red, you're in negative correlation. And you can see here, the sides are often much louder than the center. And so that means it ain't mono-compatible. Okay, and over here you can kind of see it in this view. By how wide it is, you should typically have something that's more of a vertical oval. If it starts going completely circular or even more of a horizontal oval, that means you're in negative correlation. But what's cool about this meter is it actually kind of shows you with these black lines the direction that the phasing is moving. Let's make this a little more mono-compatible again. And you can see that there's some sounds that originate over in the left field and they move in this direction. They move to the right. And let's find our oscillator again. If we flip the phase around to a positive value, now you're going to see the lines originate here and kind of keep moving to the left. So this is also kind of a quick and dirty way to see what the actual left to right movement of the stereo field is doing. Your brain can't really distinguish that much granularity, but this kind of meter can pick that up for you. So sometimes, depending on what kind of effect you want, and you can also see this center red line is also an indicator of where the signal's starting. It's starting a little left. Well, it's actually kind of depends. The meter takes a little while to reset. Yeah, it starts in the center, but then it wobbles. The whole center point wobbles a little bit to the left and then wobbles a teeny bit to the right. That's like the phantom center line, that red line. Now it's wobbling back and forth, that phantom center. And the tilt of this whole thing, like if something about your phasing or your interaction with the sound is somehow making it tilt towards a perceivable right side or right speaker, you'll actually see this vertical line tilt in this direction if it's too much balanced towards the right, or you'll see it tilt in this direction if it's balanced a little bit too much towards the left. So it's a really helpful meter. I recommend you get that. This is my basic sound design scopes. I always want to look at the stereo carefully. I always want to look at the oscilloscope split into left and right usually, but also sometimes mid and side. Like this is what the mid signal looks like, the orange one, and the side is actually this blue square wave looking thing. And that's what's kind of making that fun movement in the sound, are those two waves in the mid and the side. And if we wanted to hear those separately, I've got that set up over here. Let me make this a little more wider again. And we're going to turn off the left and the right and just solo the mid channel. So here's what the mid sounds like. And here's what the right, the side sounds like. Hear how this is a little more square wavy with a lot of edge and movement to it? It's got that hollow square wave sound, whereas the mid still sounds more like the saw wave. And the two of them together, well, actually that won't work because I'm splitting them and they're stereo. They're not stereo at that point anymore, but the two of them together sound like this. So I think that's everything I wanted to say. Yeah, be careful with this one. It's only two voices. You're still going to have to use a stereo width control to control its mono compatibility. Use scopes. They're very helpful. And you know, there's nothing fancy about these settings. You can just copy these settings out of my video and they'll put you in good shape. I guess I will show you one thing about the way I use this oscilloscope. When you want to see individual waves and keep them more or less still, the best mode to use is this key tracked trigger mode. If I let it free run, it's hard to see, right? So this kind of tries to hold it stationary if it can recognize the pitch you're playing, and it'll try and match the windowing of the oscilloscope to your pitch. And let's make this no longer stereo. Okay. The other thing that's useful is the scale. It's useful to just, if you want to zoom in or zoom out or slow this down, like a really low note, like let's make this lower. Okay, you can see how it doesn't quite fit anymore. And it also is moving a little bit because at this low pitch, the oscilloscope's having a little trouble like locking in the window size. So that's what this offset is for. If we put this at 0, see, it's showing us the real length of the waveform And so it can't hold it still at all. If we put it down 1 octave, it's effectively shortening the waveform just for the oscilloscope, but it's still not short enough. So let's put it down 2 octaves. 24. Now it looks like it did before, and it's mostly holding it still. There's a little bit of wiggling, but at least you can see the shape of the waveform. If we put this back up to where it was, right? I had this at an offset of -12. And if I didn't have any offset, that's how long the waveform really is. But again, it's bouncing around too much. Now, another way to hold the waveform kind of still and adjust it is with this hold value, but it's literally holding it for a certain number of milliseconds, so it's not really showing you real-time changes as well. Like if I detune this again, let's do it with the Unison, and let's just spread this stack out a little bit again. And let's turn the volume down. Oh, not with that though. Like this. Okay, so you can see it's bouncing around again because my offset's too high. This is the actual shape of the waveform, the actual length. But you can slow it down by increasing the hold time. But see, it's just capturing a snapshot in time. And so it just depends where the waveform is at. It's kind of jittery. So that's why I say it's better to have no hold time and to use this offset with key follow and key follow to slow it down as you need to. And typically you want to do it in pure octaves. Let's see what's going on here. That shouldn't be jumping. Take it. Oh, because I made it positive offset, so it's even longer. My bad. I want to make it a negative offset. -12. There we go. Okay, so you can just, depending on how long or short your waveform is, you can just play with these offset values in octaves, usually negative, to slow it down and stabilize it. So that's my trick for using the oscilloscope. And then the spectrum analyzer, when you set that up, I find it most useful almost always to just have at a glance what's the difference between my mid signal and my side signal, because again, if they're right on top of each other, you know you have monocompatibility issues. Okay. I guess the last thing I can show you is there are other ways to deal with monocompatibility issues that don't require like changing the entire mid-side balance for the entire spectrum of the side signal. That's what this is doing. It's taking the entire side signal and just dropping it in volume. Another way you could do this, if you had too much detune going on. Let me get rid of this. And let's also get rid of this. And make sure we've got some unison happening. But this time, well, actually not that way. This time I'm going to do it. Yeah, let's go back to here and do it this way. We'll put unison on the stereo again. On the pan, rather. Okay, so we got a little bit of a monocompatibility problem, right? But let's say for whatever reason you don't want to use the width control to drag the entire side spectrum down, because a lot of times what we hear what most humans perceive quickly as wide sounding is actually happening here in this region from about 100 hertz to about 600 hertz, right here. This is where we hear most of the width in a sound. And so sometimes you can improve monocompatibility without destroying potentially interesting things that you like that are happening up in the higher frequencies is to use a low pass filter only on the side signal to make this area of the side lower, but not mess with this area of the side. Now, your mileage may vary, a lot depends on the sound and other things you're trying to accomplish, but this is basically how you would do that in the grid. The first thing we want to do is take that stereo signal coming out of the detuned stereo signal coming out of the mixer. And we're going to want to split it into a stereo splitter because we want to grab the mid and side signals. And we're going to disconnect this and we're going to add on the other side, we need to add the stereo merge again. And let's spread these apart so you can see things a little better. Remember that I'm only using this so we could do solo stuff. This isn't part of what I'm showing you. So let's connect that up and let's connect the mid and the side. And now we hear what we have been hearing. All right, it's the same as before. It's just we're taking the stereo signal, we're splitting it into mid and side, we're connecting the mid and side and merging them back together. So this is just a stereo signal again, and then it's coming in here and going out to left and right with respective hard panning. Okay, so how do we put a low pass filter only on the side? Well, okay, in the grid, that's really simple. You do it by grabbing a high pass. We want a high pass filter. And just grab it down here and drop it on the side signal. And we're going to take it all the way down so it's not really doing anything. And it's going to be the same as we've been hearing. But now, if I start cranking this up, you can see the gap over here in the low end between the mid and the side is increasing. See, no gap, big gap, no gap, big gap. And we're not affecting up here as much. Okay, I mean, I've got the filter point way up here, but you know, you can kind of fine tune at what point the signals start splitting apart. And let's hear it in stereo. See, that's very mono sounding again because the side signal is so low now. Very stereo, but not very mono compatible. And somewhere in the middle, we're basically taking the lower frequency sounds and making them quieter. So we're perceiving less width down here in the area where you hear width. Okay, so this is another technique you can use. Just depends. Certain sounds that you're trying to tweak and fix for mono compatibility will respond a little better to this method. Other sounds will respond just fine to just broadly taking the entire side signal and moving it up or down relative to the mid signal. So there you go. That's pretty much everything I can think to tell you about doing Unison and some of the tricky aspects of doing it in the grid. I hope you found this useful, and I'll see you next time. Bye-bye.